As you guys know, I've been working on Linux for a long time. I'm a member of the Samba team. My focus has been on the kernel code and on, to a lesser extent, on some of the user space utilities like cifs-utils. I work for Microsoft, but I don't work in the areas like, for example, the quick discussion I've been having with Nick Banks. These authentication discussions with Steve Cifs and guys like that. Those guys aren't any on my team. I work in Azure storage, so optimizing Linux access to the cloud is my passion. But there are so many things going on in the Linux kernel. It's a very exciting time. I'm going to give at the beginning, I'm going to give a little bit of an overview of what's been going on in the Linux file system layer, because it's kind of an interesting story. And some of you guys coming from the Samba user space world may be curious about what's going on more generally in file systems in Linux. Then I'll talk a little bit about KSMBD, the kernel server. You guys can go to git.samba.org and see the source for that if you want. It's also in current Linux kernels. And then I'll talk about the recent client improvements to the kernel and to the utilities, and talk about where we're going, what to look forward to, some of the things that are being discussed. And I think the most important thing, maybe one of the most important lessons learned from Samba, is that testing matters, and better testing matters. I think everybody can agree that SMB torture and the automated testing that Samba does has been incredibly valuable. And so as we look at the kernel client, how can we improve testing, and some of the work that Ronnie, Aurelian, and others have done, it's a very exciting time to see quality improving as well, and I'll finish with that. So as you guys probably know, Linux has strange names. The frozen wasteland seemed to fit pretty well last year with the lockdown, with people stuck at home feeling like they're in a frozen wasteland in 5.13 kernel. Fast forward a year from then, now Linus, making a pun on some sporting event that you guys may have heard of, released the superb owl. Now, I like that particularly because I went to Rice, and Rice University's mascot is an owl, so I thought that was kind of cool. And superb owls are those that have kind of unconventional wisdom, and that I think it applies to the Samba team. The unconventional wisdom of the superb owl. So I like that, but I think he was referring to some sporting event. Okay, so for those of you who aren't familiar, the storage guys in Linux get together in an invitation-only event called the LSFMM Summit. So they divide it into multiple tracks: memory management, block drivers, and file systems. And you can see the picture here of the attendees. You can also see that they've added the dynamic tracing eBPF people. So you can see Brendan Gregg, the famous guy there. You may recognize many faces here. These are many well-known Linux people. And that was a few weeks ago, was the first in-person event. So when I saw this, and I enjoyed going there, it reminded me that I'm really looking forward to being in person at sambaXP next year, because the amount you get done in person is huge, especially with the hallway conversations. But I brought this up partly because some of these things affect Samba and are important for Samba, some of the discussion points. Not just performance enhancements in the file system, but there are many features that are important for Samba going forward. Okay, so what are some of the things that have been talked about the file system layer for Linux, a high level, and then we'll dive into the SMB client piece. As you probably know, I think Metz referred to IOU ring. The async IO API has been completely redesigned in Linux, and the new way is to not use AIO, it's to use IOU ring. But there's a new mechanism as well for dealing with dynamic page sizes, different page sizes, not just 4K pages like the dark ages, this concept of folios, but it's also led to a complete redesign of the page cache, not just the in-memory one, but also the offline page cache, FS cache. But that's created problems for various file systems. So Dave Howells created a mapping layer for network file systems called NetFS. NFS is lagging a bit on this, but Ceph and well, 9P is very primitive, so that's less of an issue. But Ceph and AFS and now SMB are supporting this, and NFS is starting to. But this new page cache mechanism not only provides more parallelism, which is good for mounting to things like Samba, but also addresses many long-standing features that have been missing from the page cache. So I do recommend you look at LWN, which has good articles on this, and take a look at what Matthew Wilcox has been doing in folios, because it'll significantly it could significantly affect Samba server performance. Also, there were a couple talks. I gave one short talk about suggestions for what SMB attributes we could query from StatX. So, you know, the kinds of things like offline, right? Samba should be able to know that a file is offline and report it to Windows and Macs. We should also be able to get better FS info. And as you probably know, we've moved to this FA Notify API, kind of away from iNotify. Amir gave a talk a little bit about that. And I also gave a talk about how, you know, currently the irony of iNotify was added because of Samba, but Samba server, but it doesn't support SMB. So from a remote perspective, it only works for local file systems, not remote. So I talked about that a little bit. So Linux clients could get the same benefit that Windows clients do from iNotify or FA Notify notifications. So Amir gave a little bit of discussion about changes to that. So, you know, for Samba, you may want to look at the LWN article on that. Christian Bronner talked a lot about ID map mounts that may have some synergy as well. The NFS community doesn't really have a good encryption solution. So there was a large discussion Chuck Lever led on how they can handle encryption with TLS. But that's kind of difficult because only part of that support is in the kernel, and upcalling to user space would be bad for performance. But we, of course, from the SMB perspective, are more interested in how we could get quick driver in the kernel. There's a number of candidate drivers, and we'll talk about that. So there's a couple other things. Obviously, as things move to the cloud, you get very long latency, but we also have a lot of discussions at the File System Summit in the file system world in Linux about, you know, how to better integrate super fast storage and what that means, you know, NVMe and NVMe over fabrics and RDMA. In our case, SMB direct. What does that mean? How does it change things in the file system layer? So lots of exciting stuff going on at a general level. Specifically, file system activity went down a little bit for the last 6 months, but up from a couple of years ago. It's almost 7% of the total kernel changes. As you know, the Linux kernel is unbelievably huge. We had over 5,000 file system change sets last year, and the kernel file systems are 1 million lines of code. I think that sounds huge until I look at Samba, which is more than 3 times that. So, you know, what's the most when you look at Linux, where are people doing the most work on file systems? Well, BTRFS and XFS, same as it was 5-6 years ago. The VFS mapping layer itself had a huge number of changes, 1,022 change sets, spread over a lot of different workloads and patterns. Typically, Linux has been adding a few sys calls for the file system every year. It didn't seem to this year. I'm a little curious why. Maybe they're still letting IOU rings settle in. Anyway, the third and fourth most active file systems were NFS client and SMB client. As you probably know, the NFS client had been, the activity had been way down for many years, but this year that it picked up a little bit. Still curious why. Maybe cleanup stuff, maybe PNFS stuff, but it's an interesting thing to look at to see where the NFS changes are. On the SMB side, I'll dive into that and talk about it. But one thing I found interesting was I looked at the SMB client changes by line of code instead of looking at it from just change sets, and it was fascinating. The cifs client had almost twice as many lines changed as the NFS client. On the server side, of course, the SMB server, the kernel server is more active than NFS server. I think you guys know recently that the NFS server maintainer kind of retired. So in any case, the kernel server for KSMBD was introduced in the 5.15 kernel, but this is a tiny amount of activity compared to Samba. So I do want to put this in perspective, that Samba activity is way bigger than, you know, any of the Linux kernel servers, whether NFS or SMB. Okay, so 273 change sets. cifs is now 60,000 lines of code. It grew a little bit. A lot of cleanup too. We're also merging more common code, so server and client are using more common code now. KSMBD is quite small. It's probably about 10 times smaller than the equivalent file server code in Samba, but it has the benefit of being able to get rid of things, right? So doesn't support LANman, doesn't support NTLM-v1, it doesn't support SMB1. So it's able to it's easier to read, easier to follow because the code's so much smaller. It's able to throw out things that Samba, for legacy reasons, has to support. But Samba, as you can tell, is orders of magnitude bigger. I'm looking forward to in-person PlugFest a lot, but there is a virtual PlugFest. I say this week. It's actually in 2 weeks. Sorry. So the in-person PlugFest, maybe let's cross our fingers for the fall. I'm hoping. But at least there'll be a virtual PlugFest at the SNIA EMEA event in 2 weeks. Anyway, we talk generally about what are the goals of SMB, right? I think Ralph may have briefly touched on this as well. What are we trying to do? We're trying to make SMB sort of the generic commodity protocol to get at file data. There's lots of reasons why it's easier to get at files than it is trying to get them through remote blocks. We had a fascinating time 3 years ago at the Filesystems Summit, listening to the block device guys having an insane argument about who's responsible for corrupting data, and all the file system people are basically saying, you're not using a file system. Without a file system, there are many, many things that can't be done safely in a distributed world. And SMB has been around forever. It's extremely well documented. It has lots of extensions. And it's sort of the generic way to access files. So how do we make that work? Unfortunately, the problem we have is that it came from a Windows and an OS2 world years ago. And even though it's very extensible and the Macs have done a great job extending it, we really need those SMB3.1.1 POSIX extensions that Ralph touched on in the Samba server, not just in the kernel server. So as Linux evolves, we can quickly add these syscalls, quickly add these fsctls, quickly add these new flags for fallocate. So we don't end up waiting 8 years like we might if it was the NFS world waiting on a new RFC. We need to be adapting as Linux changes because as you can imagine, Linux has no restriction on adding syscalls. It has no restriction on adding new flags. And it continues to grow and change, and our protocol needs to grow to match that. Okay, so Namjay provided me some slides so I can give you some background on the kernel server. As you probably know, it's hosted on samba.org, and it's made some really exciting progress. There was some interesting drama before it got merged. It got merged into the 515 RC1 merge window. It had been getting reviews for about 5 months before it went into Linux Next, and then was in Linux Next for many months. Got a lot of reviews, and then the minute it came in, lots of security problems were found. So those were addressed in that early period, 515 and 516 largely. And as I mentioned, it had the benefit of removing a lot of the less secure protocols and features. The name was changed from cifs-d to SMBD, KSMBD to avoid conflicting with Samba's SMBD and being confusing. But this naming should make Ned happy because we want to avoid using that 4-letter word cifs. On my end, I'm going to try to change the cif source directory from cifs to SMBFS client, but we've already changed the common code directory to SMBFS common, and you can already do a mount -t SMB3. And if you do that, you can't even use cifs at all, even if it's built into the module. And of course, as you know, modern clients negotiate SMB3, not the old stuff. So some of the priorities for the kernel server was making sure some of the key security fixes were in. So they added AES 256 GCM, that's sort of military grade encryption early on. Here's a slide that shows the accelerated encryption performance. Because we could take advantage of the hardware offload, and you can see the performance here. Kerberos support was another priority. It upcalls through KSMBD mount D using libkrb5 to support Kerber authentication. Here's an example of how it's structured. I think there's opportunities to continue to use more of Samba's user space libraries. And as Ralph noted as well, that over time we need to move more and more of these RPC calls. There's a few RPC calls that the kernel can handle or the user space code can handle current stuff, but many, many more RPC calls, like maybe the witness protocol. could be done with this new RPC design of Samba server. So one of the early features that was added was support for duplicate extents, reflink. So if you copy a file --reflink in Linux, it invokes this duplicate extents API that was added initially for REFS, but also is supported by Samba. This is extremely useful for many fallocate operations like insert and collapse range. And in a way, it's been kind of easier for KSMBD in some ways because there's you can bypass the VFS mapping issues and the weird plugin modules that Samba has for BTRFS and XFS and other things. You can go directly to some of these kernel routines. It's a bit easier in some cases. Multi-channel. So another high priority has been supporting multi-channel. There are some channel failure scenarios that I think he's addressed by now, but were to do when I was doing these slides initially a few months ago. And as you know, multi-channel is incredibly important for improving performance. Even with a single adapter scenario with RSS, in many cases, Windows is using multi-channel even on a single adapter mount. Multi-channel provides many advantages. And I think we have some numbers we can talk about in the Linux client on a later slide on how multi-channel helps, but it was added to the kernel server. Here's an example of the query network interface call. I did notice on Samba that I was getting an error on query interfaces. I need to go recheck that on the more recently released Samba to see if, but here's an example of it to KSMBD, the formatting of the query network interface and session binding to multiple channels. And here you can see the different colors. You have write requests sent to multiple channels. So what are the kind of things working now? You got SMB Direct. He was able to get, Namjay was able to get test hardware from Chelsea.io. Windows client and actually Linux is working as well. He's addressed these performance issues. And direct releases, change notified. Okay, so here's some more recent things. More recent things he's added. A lot of it has to do with RDMA support, and I know there's been a lot of conversations with Tom Talpe and Long Lee and others, but this is kind of exciting stuff. Being able to control the read-write size through configuration up to 16 megabytes, being able to improve the compatibility with various RDMA types. And also, I think from my perspective, what's been most interesting is being able to handle soft iWarp versus soft Rocky, being able to handle both so you can do emulation in your test environment, because not all of us have RDMA cards. Right now, my RDMA cards aren't even set up, and I've got to move them to different desktop. So being able to regularly run regression tests with soft iWarp or soft Rocky is super important. And I'm kind of glad that KSMBD is now kind of broadening its support for SMB Direct on multiple types of hardware. And then being able to auto-detect the RDMA NICs without configuration. That's very exciting. Windows does this better than the Linux client now, but there's a patch I'm literally reviewing today from John Prasad to be doing the periodic querying of the network adapters so we can auto-change the number of NICs that we're connected to from the client perspective. But it's great to see that the kernel server has it, and of course the Windows client does on Windows Server. So here's some performance numbers we'll see. Here's some description of the test hardware he was running and the benchmark tool. Here's a comparison between single and multi-descriptor, some of these recent changes he did. You can see the dramatic improvements in read, and especially in write performance, but also in read performance. You can also see here the performance changes by number of connections, and also the benefit of the 16 meg versus 8 meg IO has been helpful. Okay, so this was for write performance, and here's for read performance. And for those who want to dive into some of these RDMA numbers, feel free to contact Namjay or Hunchal, and you'll have the slides as well to look at some of this data. And I think this is very exciting in terms of performance optimizations. Now, some general comments from me. If you're interested in contributing, there are some very exciting things, very cool features working on. One of the things that Ralph touched on was how to better integrate with Samba user space code, RPC stuff, for example. because there's no reason. I mean, the KSMBD kernel server is 25,000 lines of code. Even at when it's fully implementing everything it needs to, it's going to be less than a third the size of the Samba file server. It might get to 70, 80,000 lines of code someday, but the NFS server, which around forever, isn't that huge, because the kernel server is meant to be highly optimized, and we can upcall the user space for things that are not performance sensitive. So, examples we talked about, like the integration with the new RPC daemons, would be great. Namj is the maintainer. I'm co-maintaining, so the merges go through my tree. So I'm checking these things. I'm also running additional regression tests on it, and I'm working with Namj. But I spend about 90% of my time on the client part. He has a team of people. I think you probably have met Homechil, or at least dealt with him on reviews, and there's a group of additional people that have been working on the kernel server code. But there are lots of cool features. I think what's most interesting to this community might be how to integrate sanely, sensibly, with user space code where possible, and also find ways where workloads can use this hybrid model where the servers are doing what they're best at. Because obviously the intent of the kernel server isn't to replace Samba, it's to be able to deal with certain workloads like RDMA and others, and be able to handle cases where interacting directly with the kernel API improves performance, especially with the new redesign of the kernel caching layer and the VFS. Okay, so let's switch gears and talk a little bit about the client changes. This is more my passion, of course. I've been doing this for a long time. I'll give some examples of a few features that jumped out at me, and then we can give a little more broad list. So I was very excited when we were able to add support for AES GCM 256. Obviously, GCM 128 is perfectly adequate. It's very strong. But Windows had added support for the strongest encryption, and now Azure also, XSMB, the Azure server, also supports it, and KSMBD supports it. So if the server requires it, so it's a negotiate context, if the server requires it, the client will negotiate it. But you can also force it on the client. Since we don't have a registry, there's a module parm called require GCM 256. So if you load the module, or if you change this module after loading, change this parameter in sys modules after loading, then this require GCM 256 will force the client to use GCM 256. There are government accounts that want this sort of, what do they call it, military grade encryption. So I think there are arguments for using it in some cases, but GCM 128 is perfectly strong. And here's an example of a mount with require GCM 256 set on the client. Here's an example of a mount, a Wireshark trace of a mount to Windows from Linux with this. So it was a fun feature from a security perspective. There are other security features added as well, some NTLM SSP features. So let's, we can dive into some of that later. So let's see. I was trying to see if there's any, there was anything in the question Q&A thing. Okay, so performance improvements. Now, lots of performance improvements. I'll dive into a couple of them, but I'll mention a few more. So we have a new mount parameter called RA size, and we may not need to do this in the future as we integrate more and more with the new there's IOV iter changes and the new page cache design. But here's an example of mounting with 2 channels and setting RA size. We start out with something simple, just do the simplest file copy. So here we're copying a 10 gigabyte file, and between 2 VMs, downloading from Azure, it's a low-end VM, right? 140 meg per second with SMB3. That used to be the default years ago. Now SMB3.1.1 is the default. We get much faster, 201 meg per second, because in Azure we're encrypting by default. So being able to offload the encryption with SMB3.1.1, the faster AES GCM, you got 41% faster. That's great. If we went to 2 channels, though, and used RA size, we got more than 3 times faster. So having 2 channels and setting RA size to 4 meg, the effect of that is it allows more than 1 IO to be sent to the server as well, which eliminates some of the dead time on the wire. So we're much more efficiently using the network bandwidth and also the server, because we have a queue of multiple read requests. But this is a simple example of something in the last year. More than 3 times faster. So there are lots of fun places to make optimizations and to do better than many of the alternatives. Here's an example I think many of you are familiar with of this kind of workload. So these changes came from Rohith. So as you guys know, SMB has this neat feature called handle leases, and it allows deferred close, and Windows clients to take advantage of this, but Linux didn't. So an example of this would be the kind of benchmark where you open a file, write to it, close it, open it, read to it, and those benchmarks would basically have like 0 time, right? Because as they prep the file by writing to it, it's going to be cached, so reading it's not going to send data over the network. So there's kind of funny benchmark examples that would be significantly improved by this. But here's a simple example I did. So basically write some random stuff to a 2 gig file and then read from that 2 gig file. And you see this enormous improvement in performance. If you read the same file twice, the second time is 3 times faster. I think it's very cool. So being able to read the same file twice or write a file and then immediately read it back, the performance gains you get from deferred close, being able to keep it in the cache a few seconds longer is huge. Okay, so let's talk about, there's some other really good examples, by the way, that I'll get to. So there's a lot of, we got a nice performance boost from RA size, which we talked about. Ronnie at Red Hat added support for fcollapse and finsert, new additional fallocate operations by leveraging duplicate extents and kind of a neat workaround. Rohith added support for deferred close. We improved the directory cache in the root directory thanks to some of Ronnie's work. The GCM 256 we talked about added support for the shutdown ioctl, which allows you to halt new activity to better allow emergency shutdown of a mount. And we also significantly improved the error handling and mount. The mount, as you probably know, the mount API was completely redesigned by Dave Howells, and when we added support for that last year, created a couple bugs. But there's also much better error handling, and also it's much easier to do remounts, a much wider variety of cases. Okay, fallocate improvements. We can now allocate as of for 14 smaller ranges. Paolo at SUSE did some nice DFS reconnect improvements. I started work on support for the negotiate signing algorithm. And in 5.15, I think tying into some of these earlier discussions, I removed anti-LAM v1 and landman. And that was when the kernel server was also merged. Metz had asked about what about small files, like 1,000 files with 100K size. It's an interesting question when you have lots of small files that you're reading, and it's something we can follow up on. One of the things that Shyam's been looking at is some database workloads where they're reading from many files at one time. And what we're trying to figure out now is where, using eBPF, trying to figure out where the bottlenecks are, whether we have any serialization and mutexes on the client we need to worry about. What we're seeing right now actually is networking issues. Depending on the networking stack we're running on, we're seeing that one of the obstacles we have with lots of small 100K things is network. So anyway, there's a lot of data that we need to get on in it to answer Metz's question, and I think it's a really interesting question. But it's one of the things we've also struggled with is how to do sort of regression tests for performance. So how we make sure that we don't regress anything in the future. when we do these performance optimizations. In the 5.16 kernel, there was an interesting performance. So we had these performance improvements for set file info using compounding. But one of the problems with compounding is that there are cases you don't need to be using compounding. You can use an existing handle. You have the root. If you support directory releases, for example, you're always going to have the root directory handle. So there's no need for set file system or query file system stuff to be just use the existing handle you have. So there are a few places where we weren't checking to see if we already had a file handle and we were unnecessarily sending a metadata operation open across the wire. There were some good multi-channel improvements and reconnect improvements in the 5.16, and also FS cache, the offline cache. As you probably know, Dave Howells redesigned that. I also added, to try to diagnose some of the network problems, although it shouldn't be necessary, I added a mount parm TCP no delay to allow experimenting with setting that directly. One of the questions we're going to have looking forward is how we're going to monitor the network stack better to see if there's unusual queuing issues. Anyway, you get a little bit of flexibility here with this optional mount parm TCP no delay, and it may help with some performance testing. And it may even help with some workloads in avoiding the queuing delay. The 5.17 kernel, there's the redesigned FS cache, offline files caching mechanism from Dave Howells. I think the Windows has a similar kind of thing for offline caching, but there are workloads where this makes a lot of sense, especially sort of single client workloads. Also, we had some questions from server developers wanting to be able to find out more about the client that was connecting to them, so they could debug and categorize their bugs, or find out if the client experiencing a problem is one with a known bug, like an old version of RHEL or an old version of Ubuntu. So we now send, like Windows, we have this additional NTL MSSP info. There's a module on OS version info that's sent in NTL MSSP. And multi-channel code was structured. So the reason cache file handle we talked about. In the 5.18 kernel, one of the very exciting changes, which may help Samba a lot, is they added support for, sort of outside the cifs layer, but they added support for cross-mount ref links. What that means is that if you mount to share one, a BTRFS directory on Samba, and then you mount to the same server share two, you can now do a CP command between share one and share two, and do complete server offload. Before, that would basically say, oh, they're not on the same share, they're not on the same mount, so we're going to forbid it. Now, if it's the same file system, it lets the file system decide. So if I'm mounted twice to the same Samba server, I can do a copy from share to share. Now, this was a change in the VFS layer, so it didn't require any changes in Samba or any changes in the Linux kernel. But if if Samba is running on BTRFS or a file system that supports reflink, Linux client now 5.18 on will be able to do server offload even if it's not to the same share, as long as it's the same server, assuming they support duplicate extents. Reflink. The 5.19 RC1 kernel is expected Sunday, and so far, changes that I've merged so far include some very important performance optimizations from Ronnie for directory searches, allowing us to cache not just the root directory information, but also the contents of the root directory, assuming you support directory releases. So I'll be very interested in how Samba is making progress on directory release support. But as you can imagine, this significantly reduces the amount of network traffic, because Linux generally, not SMB, but Linux generally, is a very chatty operating system. Doing an ls-l on directory with 1,000 entries can cause many thousand syscalls. It's very inefficient about it calls revalidate all the time. It calls query info stat all the time. So being able to reduce the amount of network traffic by better caching metadata on directory contents is unbelievably huge performance improvement. Also, one of the most important things has been trying, multi-channel has been in the Linux kernel for quite a while, but making it stable isn't just about handling various test cases. It's also about fixing reconnect for all the weird cases where one channel goes down, or IP addresses changed on one channel and not another, or something. So these reconnect improvements have been we've been doing these over a number of releases, but I think the last major set was merged in 5.19 RC, and I think we're ready to default to multi-channel pretty soon. And there were some RDMA SMB direct improvements. One of the things that's most exciting to me is how we figure out what's going on. And if you guys haven't read Brendan Gregg's website or book, or looked at some of the eBPF resources, I think all the major companies seem to be behind eBPF. This is the way forward for tracing. In terms of specific trace points, dynamic trace points that I can turn on, there are 96 of them, you can see here. 10 more than last year. And one of our goals is, let's say you're debugging a Samba server problem. What trace point do you need? So let's be very, please contact me or one of the other SMB server client developers if you're trying to debug a server problem and you need additional client trace points. These are very cheap, easy to put in, no performance impact if they're not enabled, and they're unbelievably valuable. Whether it's dealing with crediting bugs, or whether it's dealing with RDMA bugs, or whether it's dealing with performance questions, these dynamic trace points can be incredibly helpful, since you can selectively decide which ones you turn on and off. There's also great, don't forget about the proc stats, especially if you have stats 2 enabled. You can see latencies and the slowest and fastest request by type, proc FSF's open files, debug data. These things can be very helpful in debugging server problems by combining your knowledge of what's going on in the client versus what the server's logs show. And also, I highly recommend looking at that Brendan Gregg's website. Also, the Samba wiki has some helpful data on troubleshooting. So I don't want to forget about user space tools. cifs-utils had a security release in April. In last September, it had additional features added, including the ability to view alternate data streams, some improvements to cifs-utils. There are times when it's easier to use something like cifs-utils or SMB-info or some of the other ACL tools, because SMB cackles is great, but it doesn't run on an existing mount. And also, Aurelian had the improvements for debugging. If you need the keys for Wireshark to be able to look at your encryption and your root, you can run the key dump options within SMB-info. More recently, support was added for GSS proxy. I think following up some of the Kerberos discussion, there are times when we need to be able to retrieve the Kerberos, the KRB5 credentials, and can't get them. So we now have support for being able to fall back to look at GSS proxy to try to find the KRB5 credentials. And there are also miscellaneous bug fixes. So coming soon, what are we thinking about? Extending the use of direct releases to greatly improve metadata caching. Currently, direct releases use in the client is limited to the root directory and its contents. I've partially implemented support for compression. I got maybe a third of the way through to allow compressing on the wire. As you probably see, Windows 11 has a mount parameter to allow you to do a net use with compress. I'm not sure where Samba sits on that, but I'd like to finish that up next release. StatX, I got general favorable support about returning additional attributes like offline. Talked about the FA notify improvements. Right now, you have to use a private ioctl to use it to Samba from Linux, but this would allow you to use it with your normal syscall. I think it's extremely important to going forward to work on Quick. Because there are many cases where port 445 is blocked, but there's also many performance problems that Quick solves by not having head of line blocking and better congestion control. And I talked about the redesign of Folio's cache, parallel IO. Dave Howells is sending me emails and messages every day on this. So there's a lot of work going on there. And I think, the elephant in the living room is, although the kernel server has 2/3 of the support for the POSIX extension has been in there for quite a while, we really need to make sure Samba gets that. It's in Jeremy and Volker's tree right now, but we need to get it in the mainline Samba, because one of the chief reasons people are using SMB1 right now is simply because the POSIX extensions don't exist, and we don't want to force people to use NFS simply because this piece wasn't merged into Samba. Testing improvements. Bugfests are unbelievably helpful. Buildbot has been unbelievably helpful for us, thanks to Aurelian and Paolo's work and Ronnie's work. Their test groups for various server types, Samba, Windows, the kernel server, KSMBD, Azure, multi-channel, but we also have a general group, and the number of tests we've added are huge. I just added 21 to such testing this last year. The number of tests we run against Azure is up 25%, kernel server is up 15%. We're trying to get up to about double what these are, but there's additional features that we have to do for some of these. But just today, we're looking at adding one more. There are detailed wiki pages if you want to dive into this, but this automated testing has been unbelievably helpful. Anyway, thank you guys for your time.